Hi, Assalamualaikum. My name is Aliza, and I'm going to talk on Q basic theory. Okay, first, factors contributing to packet delay. There are typically 4 factors which contribute to a packet delay in a network. Out of the 4 factors, queuing delay is the one which is most interesting and most complicated. Total delay is a processing delay, transmission delay, propagation delay, and queuing delay. Queuing delay is the time spent by the packet sitting in a queue waiting to be transmitted onto the link. The amount of time it needs to wait depends on the size of the queue. If the queue is empty, then it will be transmitted immediately. But if it's sitting behind other packets, then it's need to wait for the packets in the front to be transmitted first. Okay, in order to understand more about queuing delay, we have to step back and look at the basic of queuing theory first. Then, we will look at the simple queuing model derivation and see how we can use that to calculate the average network delay. Okay, what is the Q basic theory? Queuing theory is basically the mathematical study of waiting lines. We see queues every day in our life, whether it's a line in Starbucks, queues of vehicles on the road, packets in data networks, grocery line, and the likes. Typically speaking, a queue is formed when people arrive at a place to get some kind of service, like getting a coffee, grocery, or medical help. In queuing theory, we create a model of the queuing system so that we can predict the performance of the system for parameters like first, average number of customers waiting in a line or average queue length. Second, average time of a customer spends waiting in a line. Last but not least, how to utilize servers serving the queues are. That's all from me. I will pass the next presentation to Chandra. Thank you.
Hello, sir. I'm CHANDRATHEVAN SATHIYAMURTHY with metric ID of EA18182. My part of presentation today is components in a queuing system. Below is a representation of various components in a queuing system. From this picture, we can conclude that there are 4 compartments which the system divided into segments starting from customer arrivals, queue or waiting line, servers, and at last is exit. At a basic level of queuing system consists of 1 or more servers serving the customers. 1 or more queues in a which customer will come and line up. The length of these queues can be assumed infinite or finite length to hold customer waiting for service. First, for arrival process represents the customer arrival pattern. We will look more into the details. Secondly, service pattern, how many servers we have and the speed of the service, which is called service rate. Thirdly, queue length, how many people's queuing system can hold, 10, 20, or 200 or infinite to decide. And at last, queue discipline. This represents if the queue will be served in a first come, first serve, last come, first serve, random, etc. or manner. Typically, it's a first come, first serve, and that is what we will assume for the rest of the articles. That's the end of my presentation. Thank you.
Assalamualaikum and hi, my name is Siti Naraini binti Cik HUHAIMI, EA18120. Okay, so today I will present about the queuing model taxonomy. So in queuing theory, we use certain kind of notation, candle notation, to refer to various type of queuing system. The format of the notation is below: A or B or S or K or N and D. Arrival process, inter-arrival time distribution, it can be either of these. M M stand to represent Markovian or memory-less property like Poisson process. D stand for deterministic or constant. G for general distribution. For B service distribution, it can be either of these. M represent Markovian or memory-less property like exponential. D exponential service time. D for deterministic or constant. G general distribution. For S, number of server. Case system capacity. For example, maximum number of customer in the system including the one being served. Typically, we omit this when it infinity. N stand for population size. Usually we consider infinity for this. D discipline like FIFO, LIFO, or random. And for the majority, we only use the first three. For example, A or B or S to represent a query system. For me, thank you.